Hello everyone and welcome to Longevity Article Review number 4. My name is Jordan Marsh and today we're going to be reviewing a study about octogenarian athletes over 80 years old. I think it's a really cool one. I'm excited to tell you about it. So first, as always, here's some bird nerd time. I'm reading a book called The Bird Way by Jennifer Ackman, and that's where I'm getting most of my information right now about birds. But she quoted an ornithologist who had spent his entire career studying why birds are the color that they are. And he gave 3 rules for, general rules for the colors of birds. Males are typically flashier than females. And that mostly has to do with the fact that females are usually the ones that are staying behind to take care of the young and incubate new eggs. And so it's better for them to blend into their environment so that they're not seen as well. Adults are more colorful than youngsters, and birds are brighter in breeding season. And I thought that was interesting. Obviously, I've kind of noticed that in my very amateur bird watching experiences, but I noticed, I thought it was kind of interesting that, we have these different rules that we can use as general rules to see why they are the way that they are. But they showed this particular exception to that rule in the Eclectus roratus, or just Eclectus parrots. This green parrot on the left is the male, and the red one is the female. And it has baffled scientists for decades, apparently, why this particular species of birds, it does not kind of follow the exact same color rules as everyone else typically does. Thought that was interesting. Look up the Eclectus parrots if you're interested too. Okay. So I wanted to show you this is a little scale or a spectrum from the lowest possible VO2 max, not necessarily the lowest possible, just the one at which we lose some of our independence, is 17.5 milliliters per kilogram per minute. And from the paper it said this: 17.5 is the prognostic exercise capacity for increased risk of mortality and has recently been shown to be a more powerful predictor of mortality than established risk factors for cardiovascular disease. So there's a cool graph coming up where I'll kind of show you that floor. At 17.5, that's typically, once you drop below that, that's typically where you're losing kind of the independence of your life and you need a lot of care or help. And then on the higher end, the highest end of VO2 max, there's been VO2 maxes recorded above 90. And so this kind of represents the largest possible cardiorespiratory reserve in humans, about 73 milliliters per kilogram per minute. And so this study I thought was interesting because at first, started by mentioning this cardiorespiratory reserve that we're capable of as human beings. And what they said was there's little information on VO2 max and corresponding cardiorespiratory reserve in relationship to lifelong physical activity patterns available in individuals greater than 80 years of age. So this is all about longevity. We're interested in living as long as possible. We know that if our VO2 max is as high as possible for as long as possible, we have a better chance of living longer. And so this study took 80-year-olds, literal 80-year-olds, and decided to try and measure the differences in their VO2 max and other things. So let's get further into some of their methods. So on the left, we have octogenarian athletes, and I'll tell you more about their inclusion criteria in a bit. And then we have on the right, untrained octogenarians, which basically just means we have to be at least 80 years old, and one group is going to be really fit and have a lot of history of exercise, and the other is not, and we're just going to measure differences between them. So there was 9 octogenarian athletes. They were all masters cross-country skiers in Sweden, and typically were Olympians and had a prolific athletic experience. They had to have a minimum of 50 years of consistent exercise training, which means about an average of 8 hours per week and 4 to 6 days per week, which is pretty intense. I'm 31, so I would need to start getting way into exercise right now to be even close to these guys in my 80th year. They also have to have no more than 6 months of no training at any time in the last 50 years. So they really are kind of lifelong athletes. The untrained octogenarians, we had 6 of these individuals. They had to have no history of exercise beyond just activities of daily living. I'm sure, at least at this stage in their life. And they were recruited from Muncie, Indiana. And we're going to compare these two. There's some exclusion criteria, and I list all those here. We're trying to exclude those that might not be in the best health. So truly, these untrained octogenarians are actually pretty healthy individuals, but they just haven't exercised as much as these octogenarian athletes have. And so I thought that this comparison would be interesting. As you can see here, the age for the octogenarian athletes was 81 plus or minus 1, and our untrained octogenarians were 82 plus or minus 2. The only thing that was significantly different between the two was their BMI. So the untrained octogenarians were around 26, and the athletes were around 23. And yeah, lean body mass was about the same, hemoglobin and hematocrit was about the same. We also did what they did was they actually measured their daily activity. And so the daily steps, as you can see here, the octogenarians were approaching 10,000 steps per day, while those that were untrained were more around 5,000 steps per day, which again is still pretty significant for an 80-year-old, keep in mind. So here's what they did. They measured daily physical activity. I mentioned the pedometer that we used to measure their steps. We did VO2 max testing for each of them. We also did some DEXA scans, and honestly, I don't really know why, except for the lean body mass measurement that we had in the last slide. So I'm kind of bummed that we didn't get more information on their DEXA scans, but I digress. And then we did muscle biopsies. So in my last LAR, or longevity article review, we talked about using muscle biopsies to measure the difference between the quality and quantity of mitochondria in different types of athletes, and we kind of do that here the same. And so we were specifically measuring both skeletal muscle enzymes and then skeletal muscle mRNA, and those are some of the things that we came up with our results in further sections. Okay, so here are the results. I think the first thing that my eye kind of goes to with this stuff is VO2 max, and so this is VO2 max as it's typically produced in milliliters per kilogram per minute. And you can see that the octogenarian athletes had a VO2 max of 38 plus or minus 1, and the untrained octogenarians were around 21 plus or minus 1, which is huge. Other things were very interesting. I mean, they measured heart rate, which was pretty variable and kind of hard to pin down, so there's not necessarily much to see there. But then their final workload in watts, or just the amount of power that they could produce during their VO2 max testing exercise, was significant. So there was definitely a difference in how much power the athletes could produce versus those that were not as trained. And so this is a really cool graph, and I do want to talk a little bit about it here. So as you can see, we have VO2 max on the y-axis, and we have age on the x. And a well-known fact is that VO2 max naturally is just going to decrease with age. I had a VO2 max of 39 when I was 30 years old, which is like right there. So I was less than average. I hope that that's been improving ever since. But as you can see, my VO2 max, if I didn't do any more exercise the rest of my life, would likely follow this same trajectory and come all the way down to here. But, these were my untrained octogenarians, and these are my octogenarian athletes. And so, that's why I was saying it's just kind of insane that some of their VO2 maxes were literally at the same level as mine, even as a 30-year-old. And so, as you can see, that's a pretty stark difference. We can see that their VO2 max is obviously in a much better place. They've mostly been able to ward off the effects of aging, and that their VO2 max, or their cardiorespiratory reserve, is so high. And so that stands to give them a much better chance of not reaching this level, which I spoke about earlier, right here. So there's a study that's been done that states that around 17.5 is kind of when we cross over a threshold from independence to dependence and an increased risk of mortality. And so the better able we are to avoid that line as we age, the more that we will likely be able to live longer. So I think that's a really fascinating graph that shows a lot of cool things. So These are also some results from their muscle biopsies. So in my last review, I talked a lot about citrate synthase that sits on the membrane surface of mitochondria. Of course, octogenarian athletes had a statistically significant increase in citrate synthase over those that were untrained, and also with beta HAD, or beta hydroxyacyl-CoA dehydrogenase. So beta HAD plays a crucial role in the fatty acid oxidation pathway, or just in the pathway that controls breaking down fats. And so athletes had both statistically significant increases in that versus those that were not. Citrate synthase specifically was plus 54% in the athletes compared to the untrained, and beta HAD was plus 42% in the athletes compared to the beta HAD. This is a graph showing the increase in PGC1 alpha and TFAM. Both of these proteins play a crucial role in mitochondrial biogenesis, or basically just the process by which we increase our mitochondria. And so, as you can see here, the athletes had, again, statistically significant increases in that, which bodes well for them. That means that they're going to be able to increase the amount of mitochondria in their cells. That's going to increase the metabolic capacities of their cells and likely mean that they're going to be able to use their cells for much longer than those that are untrained. So 3 good things. As we can see, the octogenarian athletes had exceptional aerobic capacity, and that served them well in their 9th decade of life. The metabolic health of these athletes is also much greater, so we know that it's likely that the exercise that we do helps to really improve our ability to increase both our aerobic capacity and our metabolic health. And it serves as some inspiration. If anything, this proves that humans can maintain good aerobic health well into their 9th decade. However, I should note that these were literally records for the highest VO2 max that the exercise science community had seen in 80-year-olds. So while that can serve as inspiration, here's some things to consider as well. And I'll start with the last one. It's certainly inspirational, but is it attainable? It's difficult to compete against world-class athletes. And I think we might try and set some unrealistic expectations for ourselves if we use this as a guide. So just remember, of course, it's possible. And if you're willing to do it, then go for it. But make sure that it's attainable and it doesn't stress you out. Again, this is a small sample size and only men. I'm finding that most of the research articles that I'm reviewing mostly have men, and I think that's somewhat concerning. So only 15 subjects total in the study, and they are all men, so we might need a larger sample size to really flesh out these differences. And then again, I mentioned this, but what about the DEXA scan? The only thing that they gave us was that they had measured their lean body mass, and that was basically the same, about 50, I think it was about 50 pounds, plus or minus 2. So I would have liked more information on maybe their visceral fat, their subcutaneous fat, to see kind of other examples of their metabolic health. So thank you so much. I appreciate you coming. Bye.